Okay, in this screencast, you're going to learn about compound probability and how to use charts, tables, and tree diagrams to help you get through it. So the first problem talks about Jordan wants to order pizza from the local pizza shop. He can choose thin or thick crust, so that's important. And then he can also choose one topping. He's got plain cheese, pepperoni, or sausage, also important. So in the end, we have to figure out all the possible pizza options that he can buy. So when you're using a chart, the first thing to know is that you can only do it when you're using two events. So in this case, our topping is the one event, and then our crust is another event. So this time we're only comparing two, so that'd be something good to jot down. Only for two events. So if I make a chart here, I have my two options for the crust, and then three options for the topping. Okay, so then you can kind of do what we were doing in class and match up the options. So like I'd have cheese, thin, cheese, thick, pepperoni, thin, pepperoni, thick, sausage, thin pizza, oops, sausage, thin pizza. Okay, so then I can look at my table. 1, 2, 3, 4, 5, 6 possible outcomes that he can order. So that's how you can use a chart to help you find your total outcomes. Okay, making a list. A list is pretty self-explanatory, but you would do thin, cheese, thick cheese. You're just listing them out. Thin pepperoni. Oop. Thick pepperoni. Thin sausage. But our total outcomes is never going to change. So we still have 6 different outcomes when we look at our list. The last one is a tree diagram. So you first start with one of the events. I would pick whichever one has the most first. So in this case, our event with the toppings has more choices. And list them kind of on the top. And then like a tree, you're going to branch out and kind of put your crust options. So that when you kind of like read your tree diagram, you can also find outcomes like cheese, I'm trying to highlight this, cheese thin, thick would be an option, cheese thin. So when you're reading your tree diagram, you have to make sure you read all the way down. So in this case, we would still have 6 options because I got cheese thick, cheese thin, pepperoni thick, pepperoni thin, sausage thick, sausage thin. So our sample space that we talked about a couple days ago is all our possibilities. So we'd have cheese thin, cheese thick, sausage thin, sausage thick. Try to squeeze these in. Pepperoni thin, pepperoni thick. So then what's the probability of choosing a pizza that has a thick crust and pepperoni toppings? So that would mean, okay, I need to find all my thick ones, and it has to have a pepperoni. So that would be this one. So I got only one option out of 6 possibilities. And you could go and do your percents and so forth, but for now, we can just say that it has a 1/6 possibility. And the reason why this is a compound probability is because we're comparing those 2 events versus just what's the probability of getting a cheese pizza? Okay? So let's move on to the second page. All right, so at a local ice cream shop, Claire can choose her ice cream to be in a cup, sugar cone, waffle cone. She can then choose if she wants vanilla, chocolate, or strawberry. She can finally pick between sprinkles, hot fudge for toppings. We need to find all the possible ice cream options that Claire could order. So I'm going to use a tree diagram. I like them. They're a little bit shorter sometimes because you can abbreviate a little bit more. So I'm going to start with the cup, sugar cone, waffle cone. And then from there, I'm going to branch out 3 times because I have vanilla, chocolate, or strawberry. But I got to do it from each type of way to hold your ice cream. And then from each of those, we have the sprinkles or hot fudge. So if I have to find all my outcomes here, remember you have to read through, so you'd have like 1, 2, 3, 4. If you keep going and count all the way through your tree diagram, you should get 18 outcomes. But we can already tell that it's kind of getting like really long with our tree diagram or a chart. Well, you can't use a chart for this one because we're comparing more than 2 events. But, a list, stuff like that. So there's kind of a shortcut into thinking of this. So if I look, how many ways do I have that can hold the ice cream? Okay, well, I got cup, sugar cone, waffle cone. That's 3. And then if I multiply it by how many different flavors, vanilla, chocolate, strawberry, that's 3. And then I have just the sprinkles and fudge, that's 2. So if I multiply this together, if I just need to know my outcomes, 3 times 3 is 9, 9 times 2, 18. So that's a connection. If you just need to know your outcomes, you can create the multiplication versus your tree diagram or list or table. However, if it says you have to make one, then you're going to have to make one. So now what's the probability of choosing a sugar cone with strawberry ice cream and sprinkles? All right, so let's try to find that in our little, got sugar cone, strawberry, sprinkles. There's only one. Maybe we should not use yellow here. Here we go. Whoa. Whoops. Okay, so that'd be 1 out of our 18 outcomes. Let's change that up a little bit more. Okay. And then if we wanted to know the probability that she'll choose an ice cream combination that will have chocolate, okay, well, all of these have chocolate. This is my chocolate. So I got 1, 2, 3, 4, 5, 6 options out of my 18, or I can also say 1/3. Okay, so then in our final example, we have a jar that consists of 21 candies. 12 are green and 9 are blue. William randomly picked a candy from the jar and ate it. He then picked another candy right after. What's the probability that the first candy is blue and the second candy is green? All right, well, I don't really want to sit here. I got 21 candies. There's so many possibilities, which one you're going to pick. So let's relate that multiplication piece down here. All right, so what's the probability that it's just going to be blue on that first piece? All right, well, I got 9, and they told me there's 21. Okay, so that's my first probability. But then, if we kind of read it, he eats the candy. So if I'm eating it, now my probability is not out of 21, it's out of 20. So when I go for my second candy being green, all right, there's 12 green in there still because if you think about it, I didn't eat a green, but my total has been changed. So now I go and I just multiply straight across. So 108 over 420 is about 26% chance that you would get this combination of choosing the blue and then choosing the green. Okay, so let's move on to the next one. What's the probability that the first is green, second is blue? All right, so we're pretending that they're all back in our bag. So my first being green will be 12 out of 21. Okay, but I ate my green, so now my total's changed. It's 20, and this time I want blue, so still have 9 blue to start with. So again, I get the same probability if I just switched which color I'm going for. Okay, the third one. What's the probability that the first candy is green and the second candy is green? All right, so green would be 12 out of 21. But I ate the green, so now I only have 11 out of 20. So it'd be 132 out of 420, which is about a 32% chance. Okay, and the last one, what's the probability that the first is blue, second is blue? Okay, it's out of 21, 9 of them are blue. I eat one, so my total's changed, and my amount of blue. Giving me 72 out of 420, which is about a 17% chance. So again, you just learned how to do compound probability using some tree diagrams, using multiplication. If you don't need a tree diagram, if you need to go back and replay something, feel free.